Ever wondered how to deploy containers in Docker like a pro? In the vast universe of software development, Docker and container deployment stands as a beacon of efficiency and versatility. It's a tool that can transform the way you manage your applications, streamline workflows, and bring your ideas to life. Whether you're a seasoned developer or a curious newcomer, understanding Docker is an invaluable skill in today's tech-driven world. Stay tuned to unlock the mysteries of Docker and container deployment. First things first, what is Docker? Well, let's delve into it. Docker is an open-source platform that automates the deployment, scaling, and management of applications. It does this by encapsulating applications into containers. Now, what's a container, you ask? Imagine a container as a lightweight, standalone, executable package that includes everything needed to run a piece of software, including the code, a runtime, libraries, environment variables, and config files. Containers are designed to run on any system, which solves the age-old problem of, it works on my machine. If it works in a container on your machine, it will work in a container anywhere. Pretty neat, right? But why is Docker such a big deal in the world of software development? For one, it streamlines the process of software delivery by creating a standard, consistent environment. This means developers can focus on what they do best, writing code, without worrying about system inconsistencies or version conflicts. In addition, Docker containers are isolated and secure. Each container interacts with its own file system and networking. This means if one application crashes, it doesn't affect the others. Moreover, Docker is incredibly resource efficient. Unlike traditional virtual machines that require their own operating system, Docker containers share the host system's OS. This results in less overhead and more efficient use of system resources. Docker also offers scalability. You can easily scale up by running multiple instances of a container and scale down by stopping them. This makes Docker a popular choice for microservices architecture, where each service can be packed into its own container and managed independently. Finally, Docker has a huge community and a vast library of pre-built images, which you can use as a starting point for your own applications, saving you from reinventing the wheel. So Docker is all about making software development, testing, and deployment faster and more reliable. It's like a shipping container for your code, ensuring it works the same everywhere. Now that we understand Docker and containers, it's time to dive into the deployment process. Getting started with Docker is as simple as installing it on your system. So let's dive right in. If you're using Windows, head to the Docker website and download Docker Desktop. It's a straightforward installation, just like any other Windows application. For Mac users, Docker Desktop is also available on the Docker website. Download it and follow the installer's instructions. Now, if you're a Linux user, the process is a bit different. You'll need to use your distribution's package manager. For Ubuntu, this would be apt-get. For Fedora, you'd use DNF. You'll install Docker with a simple command line, ensuring you have the latest version. Sometimes you might encounter hiccups during the installation. Common issues include outdated system versions or missing dependencies. To fix these, update your system or install the required dependencies and try again. With Docker installed, we're ready to start deploying containers. It's a big step towards mastering Docker and container deployment. Let's get excited about the journey ahead. The Docker file is the foundation of your Docker container. Just as a blueprint guides a builder, a Docker file directs Docker on how to build your container. This text document contains all the commands a user could call on the command line to assemble an image. Creating a Docker file is a breeze. Start by generating a new text file in your project directory. Name it Docker file, no extension needed. A Docker file is composed of various parts. From initializes a new build stage and sets the base image. Run executes any commands in a new layer on top of the current image and commits the results. CMD provides defaults for executing the container. There are more instructions you can use, but these three are the core of a Docker file. Each line in a Docker file generates a new layer in the Docker image, like the layers of an onion. With our Docker file ready, we're one step closer to deploying our container. Building an image is like preparing the blueprint for your container. Now, what exactly is a Docker image? It's a lightweight, standalone, executable package that includes everything needed to run a piece of software. This includes the code, a runtime, libraries, environment variables, and config files. Building an image starts with a Docker file. This file is a text document that contains all the commands a user could call on the command line to assemble that image. Using Docker build, we create an automated build that executes several command line instructions in succession. Remember, the Docker image serves as the basis for Docker containers. In a real-world analogy, if a Docker container is like a house, then the Docker image is the blueprint that guides its construction. Images are the building blocks of the Docker world. They ensure consistency across multiple deployments, regardless of the environment. With our image built, we're ready to create a Docker container. Running a Docker container is where the magic happens. This crucial step brings to life the image we've carefully constructed. We run a Docker container by using the docker run command, followed by the name of the image. This instructs Docker to initiate a new container from the image we've specified. When a Docker container runs, it is like launching a tiny self-contained operating system. It boots up, runs the application it's designed for, and then patiently waits for interaction. Docker keeps track of all running containers, allowing us to manage them efficiently. We can stop, start, or pause containers as needed with simple commands, such as docker stop or docker start, followed by the container's ID. Running containers can be viewed with the docker ps command, which displays a list of all active containers. And there you have it. With our container running, we've successfully deployed a Docker container. Deploying Docker containers is an art, and like any art, there are best practices. Let's delve into a few of them. Firstly, keep your containers lightweight. The beauty of Docker containers lies in their nimbleness. Avoid installing unnecessary packages or running unessential services. This not only reduces the startup time, but also minimizes the resources consumed. Secondly, handle data persistently. Docker containers are ephemeral, meaning they are temporary and transient. Any data created inside a container is lost when the container is removed. Therefore, it's crucial to use Docker volumes for storing data. Volumes exist independently of the container lifecycle, ensuring data persistence. Thirdly, manage your container resources. Docker, by default, does not limit the resources a container can use. However, you can impose restrictions using flags during the run command. This prevents a single container from monopolizing system resources and ensures a balanced environment. Lastly, utilize Docker Compose for multi-container applications. Docker Compose allows you to define and run multi-container applications with just one command, improving efficiency and reducing potential errors. Remember, Docker is a powerful tool, but it requires strategic handling. Keep it light, persist data, manage resources, and use Docker Compose for multi-container apps. And most importantly, continuously learn and adapt. Docker is an evolving platform, and staying updated is key. By following these best practices, you'll be a Docker deployment pro in no time. Deploying Docker containers may seem daunting, but with practice, it becomes second nature. Let's take a quick moment to recap what we've learned. We started by understanding Docker and the concept of container deployment. Then, we walked through the 4 crucial steps: installing Docker, creating a Docker file, building an image, and finally, running the container. We also touched on some best practices to ensure smooth deployments. Remember, the Docker file is your recipe, the image is your prepped meal, and the container is your oven. Keep these concepts in mind as you navigate the Docker landscape. While this might seem like a lot to take in, it's important to remember that learning is a process. As with any skill, the more you practice, the more proficient you'll become. So don't hesitate. Start deploying your own Docker containers, experiment with different scenarios, and learn from your experiences. Thanks for watching. Remember, practice makes perfect, so go deploy some Docker containers.